some of the ideas here came from some required reading to keep my CISSP up to speed. So some books I read. So kind of interesting stuff. Data is, what we're going to talk about is why. Why do we care? The presentation is organized into 3 sections: understanding the scope of the threat, reducing the scope of the threat, and then protecting against this threat. I want to try to weave through this presentation that the success of this depends on technology, and we're technologists, and I love technology, and I'm sure most of us here love technology, but it also depends in large part on people and process. And those are sometimes less fun, but equally important parts of solving or protecting our data and really protecting from anything from an IT security perspective. And then we'll talk about the conclusion. So really the big why here is that, for business folks, and I think this is the Fort Bragg one. So I'm guessing that there's a lot of government employees here or government contractors. So data is a key thing for business and for government, really. I had a, what, so it's important to us. And then I had a systems analysis and design teacher, and there was one question on every quiz. There are 3 reasons, every quiz and every test. There are 3 reasons to build any computer system: increase revenue, decrease cost, and improve relationships. And there's a 4th, because the government tells us to, right? So, and really some of this, some with data, some of that falls into that. We've talked about, GDPR is all over everything. We hear about that a lot. We hear a little less about the California Privacy Acts, but for any business that does business in the United States, if they have a presence in California, then they need to be concerned about the California Privacy Rights Act and the California Consumer Privacy Act. Depending on your business type, there's going to be other. I work for healthcare companies, so HIPAA is important to us. But depending on your business, there are going to be other standards or regulations that apply to your business. There's costs for violating these regulations. HIPAA is somewhere between $100,000 and $50,000 per violation. CCPA is $2,500 to $7,500 per violation, and GDPR is more draconian. 4% of a company's annual global revenues are 20 million euros, whichever is the larger amount. So, they really are serious about it. So there's money here. In addition to money, you're risking your reputation as a business. How many people here remember the Target data breach? No, I guess I can't see a show of hands, but that was what, 8 years ago, and yet that's still a common thing. People remember it. There's also opportunity costs. And this isn't exactly on point, but one of the illustrations of opportunity costs comes from Microsoft. And in the late 1998, 1999, they were in a battle with Netscape over browsers, over just like monopoly power in browsers. And they spent a lot of time doing that. At that same time, a couple of other companies, Apple and Google, were coming up with something called the smartphone. And they're often, there's a quote where they believe that where basically Microsoft says that they were so focused on this legislation, this battle, that they weren't focused on what was happening with phones, and so they lost the opportunity to develop an OS for phones or develop one that sold, because nobody uses it anymore, right? So So, if they had not been focused elsewhere, we might have had a different outcome in terms of which operating systems we use for our phones. So anyway, that's an illustration on opportunity cost. In order to deal with protecting our data, we have to understand the scope of the threat. And I know for me that we tend to think of data fairly narrowly, and we really need to think of data wherever it lives. We need to think about all data. I work with databases, so I focus on database data, but it's not just the data that's in databases. It's on other files and documents. So it could be flat files somewhere, it could be in any directory, it could be in any media. I've filled out forms in a doctor's office where they ask me for my name, date of birth, and social security number, and then that's a piece of paper that you're supposed to hand in. Now I never give them my social security number, and I've only ever had one doctor say they wouldn't treat me if I didn't give them my social security number, and I didn't use that doctor. But nonetheless, that's on a piece of paper, and that's sitting in some doctor's file, and that's only as protected as that whoever you handed it to is protecting it. So it's on any media. I go to these ISSA meetings, and there's a lot of conversation about outside bad actors and people penetrating the network, et cetera. And that's certainly a threat. So that's one vector. But another vector is insiders with bad intentions. Frankly, my experience with that is that I've seen one case where I know of one case where there was an insider with bad intentions, and that person no longer works for the company that they were working for at the time. And I know of another case where it was just plain ineptitude, where someone did not follow policy. It wasn't exactly bad intentions, but they didn't protect data the way they should have and the way policy dictated, and they lost their job as well. But the last one is probably, to me, the more concerning one, is that's insiders with good intentions. And this can come from, the contractor who was hired for the 90-day project, who doesn't have any idea of what the company's rules are, comes with their own thinking and their own baggage, and they have a job to do, and they're focused on getting that job done. And however, whatever the standards are, really it's whatever they need to get away with in order to get their job done. Now they have, quote unquote, have good intentions because they're good actors, but they also could be a threat in terms of our data. So in terms of how they handle the data and protect it. When we think about data, we think about data that is both typically within the application domain. That's where we tend to focus it on it. But it can also be data that is not in the application domain. By that I mean data that's on OneDrives, on Teams, on Confluence, on any, even in a folder somewhere, even in a directory somewhere, And for that type of data, I would suggest that we need to develop some standards on how that data is handled, and we need some automation in which we would say, okay, we're going to scan and make sure that you're handling the data like you think it is. So some standards might be, and the one here is like no plain text secrets like passwords in the clear. Duh. Another might be, no PII data. It wasn't too many years ago where a group I was in, we would have names and phone numbers for on call in a file in a directory somewhere. Well, that's obviously not going to fly right now anymore, but that would be considered a secret or something that should be sensitive. Intellectual property, the formula for Coke. Our company, LabCorp, we do both the drug development where we do clinical trials. So the data for clinical trials is important. I worked for Schwab at one time, and we would do companies would come to us and want us to work with them on new offerings for the stock market. Well, which companies are asking for that? That's obviously very, um, very critical data to protect. So you want to think about the standards around protecting the data based upon what the data is. Um, you also want to think about how data that's not stored on a computer system is managed, because it's all data, and that needs to be secured. And as I mentioned, I would suggest that we also um, implement scanning software that identifies and reports violations of the standards we have, and it also classifies the data. And we're going to talk a little bit about classifying the data, because I think that's an important thing to do. In security, one of the things I've noticed is that we can't, and if we don't know what our inventory is, we don't know what it is we have to protect. And that applies to data just as much as it does to other things as well. And I'd like to suggest that we classify the data in two ways. The first is based upon the value of the data to the organization. And this particular approach that I'm suggesting, I stole from Harvey. There's others, and we'll talk about in a little bit detail on another slide what these classifications mean. But I borrowed this. But net is there's some sort of classification that's based upon the business value or the risks of the business that the data is exposed. That's one way. The other way I would suggest that we handle that, we classify data also, is based upon the regulations that govern the data in question. GDPR, CPRA, et cetera, et cetera. You can see the list. So it's a twofold classification. One way is the value, the other way is the regulations that cover the data. This has some detailed stuff, and I'm not going to read it to you. And there's other approaches here that have different words to them and maybe slightly different meanings. You can pick yours, whichever works for you, or your company works for your company. But I think we need to have something like this, and we need to classify our data like this. And of course, if you're in the government, they do it probably much more discreetly than this even. But and so here right here where my cursor is my thinking around data classification. Here's the one type here, classification. Here's the other type here, and do a check check mark on one, or whichever happens to be. And I would suggest that we would classify each data store and application tool by the level of content it covers. And I'll illustrate that in another slide. Furthermore, we need to tag that data store. In the cloud, that's not so hard because there's tagging that's available in the cloud. So we could easily tag the whatever the application or data store is in the cloud. On premise, that's a little more difficult. It might be in a configuration management database, a CMDB, or some other tool that you would use. But I think we need to tag both the data store, database, file, or the application, actually, and the application. For data specifically, more mature organizations may actually tag at a more granular level. But I think if companies got at the database level, they probably get 90% of the way there. Here's just an example of classifying and tagging. So let's say we have this is a fairly simple application. We've got a web server, and I'm in health. Work for health sciences company. So we're dealing with PHI data. We're going to tag it as internal only and PHI. The data goes to an application server, and that application server is tagged as handling internal only PHI data. It's going to an AWS Postgres database, and that again is also tagged as internal PHI. Now here's one that you might miss. So that database actually logs to an audit stream, and in AWS for Postgres, it's called database activity streams. stream goes to Kinesis, to a Kinesis stream. That stream is also tagged as internal only PHI. And if it were to go to S3 storage, that the data that's audited from this database would also go into S3 storage. Now, if you have some other tools, maybe you obfuscate the data here so you can change the tags or change the level of data here, but that's more complicated than what we're getting. Am I, the group has been quiet. Are there any questions so far? Any thoughts or questions?
I don't see any in the chat.
Okay. So understanding the scope of the threat, classifying and tag, it allows the organization to develop standards and guidelines based on data classification, and it allows us to apply those standards and guidelines as well. We can easily identify where the key data resides, and then we can compare and contrast protection of similar data. So here's application A, here's application B. They handle similar sorts of data. Do we, what protections do we have for this data? Do they match up? Does it make sense? And it applies to data. Again, I think this is a theme here, wherever it resides. Media disk, someone's laptop. I'll tell a short story here. I was working for a large banking organization, which remained unnamed.
We'll bleep that out for you.
And we were doing a proof of concept for a replication tool. And I had there was a contractor on the contractor who had data on a database on the mainframe and a database on Linux. And he had downloaded some production data onto his work laptop. And he walked out, he took that work laptop with him home. Well, actually, he took that work laptop to Buffalo Wild Wings on his way home. And he always stopped at Buffalo Wild Wings on his way home. And when he came out from Buffalo Wild Wings, said laptop had been stolen out of his car. Right now, there was banking data on that laptop. That's a big deal, right? You have to disclose a data loss. That became a big deal. That was the last day he worked for the company. So my point here is that the relevancy of that story is that all our standards and classifications apply to data wherever it resides, even if it's on my laptop that walks out the door, right? It also applies to every environment, production, development, QA. And we'll talk about cloning, in my opinion, of that in a little bit. It also applies to shadow IT. This is the business user or the end user that somehow gets some data. They roll their own application, maybe their own Access spreadsheet or their whatever, and they have their thing that works real well for them, but they're using data that might be sensitive. So it's wherever it resides. It also applies to systems which process the data and tools and utilities that process the data. So I would suggest that we have to classify and tag it wherever it lives. So we talk about reducing the scope of the threat. This first one is kind of a duh, David. This is obvious, but it's obvious and yet it's broken all the time. First point, data which doesn't exist can't be stolen or compromised. Yeah, right. Point here is that we only really want to keep the detailed identifiable production data that the business or organization needs, right? We don't want to have more copies of it. We don't want to keep it longer than we need to, because the more data we have and the more places it is, the more surface area we have to protect. And those protections can break down. There's some other principles here. Limit the availability of the data, particularly detailed data, to those who need access. And we know that, right? Least privilege access. That's the principle of that. But the more detailed the data is and the more precise the data is. Right now, Data is money, and sharing data is money to organizations, and organizations are making money off of sharing data. Why is Facebook free? They share data. They run ads now, but they used to be they just share data. It's the data. Data is the thing, right? We need to establish some tight controls for data that's shared out of the organization. So that's the last principle, is that we want to establish tight controls for any data that's shared outside the organization. Maintain fewer copies of detailed operational data. I manage database teams and I work with application teams all the time. And I can't tell you the number of times that I hear from a vendor, all you have to do is push this button and you can clone that production database and use it in development for your testing. It's real easy. It takes 5 seconds. Look at us. Bing, bing. It does it. And on the enabling application development side, yeah, that's cool. My CISSP side just cringes every time I see that, because now we've taken what could be sensitive data and very easily put it into an environment that doesn't have nearly the protection and has a lot more people who can look at the data. My point is that no, we should never do that. Number one. And number two, if you do need that test data should go through some sort of masking or de-identification before it's used in a test environment, just as a must. Another question that I from a data perspective, in terms of how I see data often move in a detailed data moving to an analytical environment as is. It might be processed at the analytical level and maybe summarized, but maybe not. And my question is, does that analytical environment really need to know the identifiers, my social security number, my address for analysis? Does it need to know, geographic data about me? Does it really need to, or is it just that it's convenient and it's always been done that way? So I think we need to ask that question about the analytical environments as well, from a data perspective. We also need strict retention policies. ETL, replication, e-commerce. There's a lot of what are called so-called flat files that move along, right, that move data back and forth. When I make a payment on my bank card and I make my auto payment, I go to my Wells Fargo account and I do my bill pay. That's not paid right away. It's paid a couple of days after I schedule it. Why is that? It's because Wells Fargo sends a flat file to each payer with all the people who've paid overnight. That data flows, right? So those files flow, but those files should be retained no longer than are needed, right? And they should be kept no longer than needed. Data in databases. When I talk to application developers, this is the last thing they think about, is purging the data. They just care about getting the data out there, right? 10 years from now, we'll worry about purging the data 10 years from now. Well, this follows the same policy, right? Fewer copies. We only need detailed data for as long as we really need detailed data. And that might be regulatory. That should be a regulatory issue, regulatory item that drives the how long it needs, or some sort of data lifecycle. But we need to be able to purge that data so that we don't keep more data than we need, even in operational systems. And that needs to be a design point. And I'll tell you from my experience, it's one of the last things that they look at. Be very intentional about data sold or shared outside the organization. Food for thought. There is no way to unshare data once it's shared. Once I give you data, I've lost control of it, whatever that data is. And I may think that I'm bright and that data beyond what I've said, but people people tend to be brighter than you think they are, and there's also the law of unintended consequences. So let me give you an example. So Strava is an application that is used by, like smartwatches. I'm sorry, what did someone say? I saw something flash.
Oh, that was me. Just on that destruction of records and all that. I was just bringing up that was the crazy thing about the being in the military is that you would have to destroy records, but you would have to keep a document recording the destruction of that record and later on destroy that document while still maintaining another document of the destruction of that document. But you had records of everything. You knew what happened to those documents.
Yeah, yeah, it's kind of interesting. Well, the Strava thing, right? So Strava is like is a tool for people who work out, and they had this idea that they would allow their users to see other people who were using the application using this thing called a heat map. And so other people could use the application. You could see where other users were. And then someone looked at it on a military base, and you could see in the application where the people were on the military base who were using this application, right? And if you watched it over time, you could see where they gathered. Maybe they were here at 7, here at noon. Now, tell me, if you were wanted to a bad actor wanted to do something against a military base, would that information be interesting to you? Right? Yeah, it would. Right?
Absolutely. Even as a non-commissioned officer, I would probably use that to keep track of my soldiers, know where they're at.
Yeah, yeah, exactly. So that might not be a bad usage of the data, depending on the private. Of course, the Army, you have no privacy, right? So there's no such thing as privacy in the military. But net, you know, that's not a good thing. So that's an unintentional consequence. It was a good idea, but you just don't control. My point is, you don't control the usage of the data once it gets out. You can't control it. So, what are the good practices? And we'll talk about data use agreements a little bit more. But the first is to execute a data use agreement with every organization which is going to receive that data. I'll talk about that a little bit more. De-identify the data that you send out. Don't give them my name and address, right? They don't need my name and address. Give them something else, right? If there are key, and in every business I've worked in, there's key things that there are keys to their data, and don't share it. In the current business is succession number, which has to do with the laboratory test. When I worked for Charles Schwab, it was an order ID. There are key things that key your data. You don't share those. Make sure that the data you share, and we'll talk about some ideas about how you do this in a couple of slides, but you make sure that the data you share can't be linked back to a person. You know, and here's the deal, right? If the data is detailed enough, you can figure it out, right? Reduce precision, location, time, summarize, and let's talk about that a little bit. So data use agreement, and these are in the back of the presentation are some references, some readings, key suggested readings, right? So a data use agreement basically governs how a recipient may use the data. For example, a recipient can't use external data to re-identify subjects. So I give you data, you can only use the data the way I gave it to you, period. End of conversation, right? You can't link it to other external data. You can't say, okay, good, I'm going to share it with I'm party A, I share it with party B, and party B can't say, well, I'm going to share that with party C. Those are just some ideas about what it is, but you want to legally spell out exactly, if you're going to share it, what that person or organization really might do with the data. De-identifying data. There's a term here called pseudonymization. Pseudonymization. Okay, I can't pronounce it. All right. Basically, it's with a surrogate, right? If you're going to share data, you take that the key, whatever the key is for the data, and you replace the key with a surrogate key, and then you keep a copy of the key and the surrogate key on your side, right? Right. And then you maintain that copy of the key and the surrogate key for every external organization that you give it to. Why? Well, if they share it, chances are they'll share it with your surrogate key, and then you can go back and figure out who shared it if you find it where that shouldn't be, right? That's just an idea. So the idea here is to take the identifying data out of anything you share. And there's two terms that measure how you protect the data. One is called k-anonymity, the other is L-diversity, and they really are approaching the problem from two different perspectives. K-anonymity says, okay, I'm going to look at the data itself, and when I look at the data, I'm going to de-identify it. I'm going to focus on the whatever the key identifiers are, so that there are multiple result sets, multiple results with the same identifying attributes, right? The idea being that you had the best practices, no fewer than 5 rows on the receiving end would have the same identifier, hopefully more. So that focuses on the data itself. L-diversity says, I'm going to look at the result set, and I'm going to see if I look at the result set, is there a way using my own ingenuity that I can turn around and identify the data, even knowing information about the result set? Let me give you one probably off the wall example. So let's say that you're looking at data for the Cone Health hospital systems, and you see that Dave was in Cone Hospital in December of 2021. Well, we would know that Dave had COVID because, and not necessarily from that data, but during that period of time, the only patients that hospital saw were patients who had COVID. It was designated as a COVID hospital, right? So you didn't look at from a data perspective. I wasn't really identified specifically, but by looking at the hospital, you were able to say, well, I happen to have this other fact out here that reaches back, and now I know anyone in that sample set had COVID because I look at the results, and I know the results because of this other fact. So it's a K-anonymity looks at the data before it's published to make sure that there's no duplicates, or there's at least 5 or more um, uh, things that have the same rules that have the same key. L-diversity looks at the result set and says, can I figure it out backwards, reverse engineering? Yeah, I just a couple of suggestions. One of the suggestions here is, you can reduce the precision of an identifying attribute, identifying data like a GPS coordinate until there are k duplicate values. So that's all I wanted to say. Okay. From a people and process perspective, right? Security organizations are not going to be successful by themselves in this battle on the data side. They've got to reach out to the application architects and developers, to the data architects, and to the analytics teams. Right now, in the development community, we have this microservices architecture that everybody's doing. We have agile development, and what's happening is, 10 years ago, there'd be a waterfall, there'd be a design, it'd be a plan and everything. Now there's a desire to fail fast and to create code quickly. And it's much more bottom up. So a developer may actually create the code, and it maybe it's also much more democratic. So it's more bottom up. So if we're going to influence people to follow we've got to influence not the leaders, but the actual developers and architects in that in of the applications. From a data architects, this is a role in our organization that specifically has to do with data, and they're often heavily engaged in new products. They understand the data, and they can also help automate a process for classifying existing data. These are people who are involved in almost every new project, and if you can get them thinking like you want them thinking, they're going to help you. The analytics teams, when they look at data, they should be looking at, do I need this identified data? And we need to convince them that they do need to look at that. So it's outside our org per se, but we need to influence them. From a security assessment, right? It's fairly common to do a security assessment for a new app whenever a new application comes in, and you might grade it, right? Here's your grade. Here's where you can improve. What isn't common is to go back to that application 3, 4, 5 years later and do another assessment. Now, what's happened in the 3, 4, or 5 years is life, right? The business wants this widget, this other widget, and so that application has been modified. And and I suggest that perhaps there will be less discipline about those modifications than there were about the development in the first place. So by doing a periodic security assessment, we're going to help ourselves in the long run. Protecting against the threat. That's the last point of this. So we've all heard about least privilege access, and some of you probably are thinking about a time or a task element, but I would suggest that people who have privileged access, administrator privileges of some sort, root, sysadmin, sys, whatever you call it, that authority should only be given at specific times. So if Dave's a system is a DBA and he has system administrator authority for a particular database, Dave doesn't have that all the time. Dave only has that when he needs it. So if you steal my ID, you don't get that authority. Why? Because I don't have it. I only have it when I need it. And the person should only have it for the duration of the change or the incident, but no longer. So you're going to see some folks, if you're a work organization that hasn't done this, you're going to get some pushback from people. And there's some validity here in the sense that they do need some sort of access that might be higher than average in order to do their jobs on a day-to-day basis. But they don't need that I can do anything access. And that's what you need to really have to protect against. Applications. I can't tell you how many applications I've seen that just give themselves the highest level of authority. Why? Because it's easy. They don't have to do any work. They're busy coding their application, and they want root system administrator, DB, sysadmin, system administrator access to the database, and it's easy. But they shouldn't have it, and we need to push back against that. No monitor should have root or system administrator access, and monitors do in some cases, and I'll give you a story about that. Protect your monitoring software like Fort Knox. I was having a conversation. Actually, I had the same conversation with a couple of very good DBAs. Kind of an interesting, it's just interesting the way this works. And we were talking about encrypting a particular database at rest, and this is the monitoring database, and encrypting the data in motion encryption as well for that same database. And they were saying, well, we really should prioritize that lower than the other databases because it doesn't contain business data. And I said to them, well, it also contains a map of all the metadata that someone would need to attack the rest of the data, because it knows where everything is buried. It knows a lot of data about data. So if you get in there, you could figure out the rest of the environment. And then they both said, this was just an amazing, because at that juncture in the conversation, they both said to me, yeah, and the database instance passwords. Now, for this particular database, there is no higher authority. So if someone were able to hijack the monitor, they have the instance passwords to the databases. This is the kind of thing that we need to look out for, and we need to protect our monitoring software for that. So just a suggestion here. From a database backup perspective, take at least some air gap backups, right? If you're ever subject of a ransomware attack, you want some that can't be affected by the attack. Just a suggestion. Encryption. Data at rest encryption, there's several different types. I'm not going to read them to you. There's also what's called data in motion encryption. If you're not familiar with it, with the two of these, the data at rest is basically encrypting the data on the disk in one of a couple of different ways. Data in motion is encrypting the data over the wire, so that a man in the middle effectively can't read the data in the clear. Next slide's kind of busy, and I'm not going to read it to you. I want to make a couple of points here. One point is that storage or file system level data at rest encryption does protect the disk, but a person who has access to that directory or file, legal, whatever, they're not hacking their way in, they just have access to that file. They can still read the data, even though it's encrypted on disk, because it's not protected against them. If you use the databases encryption, TDE encryption is usually what it's called, a person who has access to the file where the database files are stored, the file system or directory where the database files are stored, that person cannot read the data. You must read the data through the database. So that's a key thing to understand. Another thing to understand about TDE encryption is that it's going to cost you. And you're like, what do you mean? Well, backups are going to be expanded by 5 times or more. So the size of your backups will increase by 5x or more. In addition to that, and I just ran into this, not just I had a conversation with this week about it. Your network is going to be impacted because the size of those backups also increased. So the data moving over the network and the size of the disk that you need to store your backups is going to increase. So just be aware of that. If you're new to that type of encryption, it's a surprise cost. Database auditing. That's another thing that's done within databases. And typically what happens is that the databases always capture events. Those events are externalized to a log of some sort, and then the logged events are analyzed. Now, just to let you know, that can be a lot of data. One not very active system that I know of, we turned all of the auditing on, and it was a terabyte a day of data from this one not terribly active database. So it can be a lot of data. So, just a warning there. What happens is you collect that audit data, and then there are tools that will analyze that audit data. You can roll your own, like Splunk or something like that. There are a number of vendor tools from companies like Imperva or IBM or others that will allow you to analyze that audit data. And some of them have their own analytical engines they're pretty good. So they're worth looking at. So you capture the data from the audit the data in the database on one side and events in the database, and then you capture and analyze it on the other side. There are costs to doing this. Capturing certain types of information can increase CPU significantly. Think more than 2 times, right? Not 10%, 2x, 3x, 4x, or more. And those results are going to vary by the database. Huge amounts of data you have to consider the storage costs and the data retention. the tension is always between the DBAs and the security folks in this. Security folks typically want to capture everything, and until they figure out how much that is. And then the database folks are going, wait, are you going to buy me 2x in server size in order so I can store my databases? And so there's a conversation there. There tends to be a rationalization that happens between the organizations about what data to capture in order to, it's a risk, hopefully a risk-based conversation. My opinion on what data should be captured, and this is my opinion, you need all activity from privileged accounts, all activity from any individual who logs on to the database. Log on, log off, failed logons, failure to authenticate, SQL or store procedures, any dynamic SQL or store procedures, and any changes to audit parameters. Those are, in my opinion, must captures. And the specifics of how you do that vary by database, but they're important to do that. You want to take a risk-based approach. You want to implement a separation of duties as much as practical. Typically, the DBA turns on auditing at the database level, but the DBA should not own that data. They should not have access to that directory where that data is stored, or the repository. Sometimes the security team will say, we want to own the setup of the audit setup, but that's often not practical. You need to classify the audit data from the database using the same classifications assigned to the database, unless somehow you're not capturing it or you're obfuscating it on the way, but you need to classify the data. This source data is detailed data, so it may need protections from unauthorized access also. And if you can, remove or obfuscate identifiers in the audit data. Anyway, hopefully, in talking to you, you have just some idea of that in terms of protecting data, that we want to understand what the scope of the threat is. There are actions we can take to reduce the threat, that there are actions we can take to protect against that reduced threat, and that our success depends on technology, people, and process. These are a couple of suggested readings. Those of you who like to read NIST things, this NISTAR 8053 is actually a pretty good article. It's older now, but it's a pretty good article that's referenced a lot of other places that talk about data protection in literature, reference back to this particular NIST article. So it's a good one. And this is a good book too, if you're interested in this topic. So, questions, conversation?
I have a couple of questions, Dave.
Sure.
Something that I'm currently really interested in and learned about is database pass-through for like SSO authentication. So, ways in which, like as an example, like if a user uses a web service that's connected to that database, right? And they're running like a report from SQL. What are some of your thoughts, as it pertains to like limiting permissions and protecting the databases with that kind of pass-through?
Well, I think that the first thing is that when you have an SSL or a TLS connection, it's typically TLS 1.2 or higher in this situation. That's data in motion encryption, so you're encrypting the data over the wire. The key there is, do they have two keys there? One is, what access do they have? Are they limited to data that they're allowed to access? Right. That's one. So it's easy to be overly broad in giving people access to data, because it gets them off your back. But what do they really need to see is one. And then the second thing is, in the audit, this is access that you need to audit. So when I talk about individual access, this is the access that you want to audit. So then you know what SQL they ran, you know when they ran it. If you have an audit tool, you'll know what the pattern is for them running it. And if they're running data that's outside their pattern. So for example, they normally do a query that um, asks for just a subset of accounts from the accounts database. But today, for some reason, they're extracting all the accounts from the accounts database, and oh, what wait, they're also looking at name and address, and they're extracting all of those. So that's out of pattern, right? So if you have if you have a tool that audits the database and that's turned on, and you have analytics that says, okay, Dave is doing this. His pattern is to do X, but today he's doing Y, right? He's getting this much data. Flag this, and I need to alert on it. That's a key. That's an important thing to do. Does that help?
For sure. And then like another thing that I was thinking about, like, controlling access and limiting permissions is service accounts. So what I've seen and read about is that a lot of times service accounts will have like the full permissions to the backend database. But when a user makes a query, instead of the permissions being assigned to a user just what they need, instead that user's query goes through that service account, which that service account has full access and returns whatever it is that they were supposed, or I guess whatever it is that they were requesting.
So typically, so the model that you're talking about would typically be in an analytics database. So in a service, so for an operational database where there are transactions occurring and you have like an application running that does that processes, for example, let's just go with a trading database, right? I'm Dave. I want to place a trade, and I log on and I place the trade. The application, you log on to the application as a client, and then you place a trade. But the code within you're running application code, and the code is what does the work. You're not doing it dynamically, right? So in that sense, there's an application server. The application server has a service account that it uses to access the database, right? And then the client, the person out here, is only allowed to do what the application lets them do, right? The application kind of gates what they're allowed to do. And the application may have some security base built on around it too. Situation you're describing is more of an analytics situation where you've got some sort of analytics engine like Business Objects, or SAS, or Tableau, right? And Tableau, and these are accessing some sort of intermediary thing, and they're given service account level access. And that's one of those ones where that's a little harder, right? Because if you collect all the data, you're going to collect a lot of data. So you really have to be discreet about what that kind of a user can do. And the better tools, like I know HANA does this, HANA can say, well, Dave is associated with this level with these accounts, right? And so Dave can do anything within these accounts. And then so the HANA is effectively gating it, even though there's a service account to the data, the backend data, there's more discrete authority built into the application in this case that is servicing the data. Even though I'm providing SQL, I'm still limited by that HANA interface. So it could be multi-tiered, is what I'm saying, right? So the database may have a service account that accesses the database, and then there may be an application. An application may access the database via service account, and it may be a query-based thing, but hopefully the application has some smarts built into it to limit what each of the users can do. then you have to do it at the database level. And you have to be careful about what each type of user is allowed to do. Does that help? And that probably
Yeah,
does.
no, that makes a lot of sense to me. Maybe that's because I just was reading about it and studying some more about it. So I'm like, yes, that makes sense. Yes, that makes sense.
Okay.
For sure. And I had another question. Early in the presentation, you were kind of showing like a diagram with the AWS RDS and the Kinesis stream and like the S3 bucket as part of the DAG classification portion. And I was kind of curious what your thoughts were on a data classification tool, such as like AWS Macy.
I'm not familiar with Macy, so I'd have to go look at it. I can
Okay,
take.
well, and I guess any data classification tool.
I think you need it. So this is one of these ones where I think you need a tool, right? You need a tool would be very, very helpful, particularly with the unstructured data. It's a little easier with structured data, less in databases. But the unstructured data in the files, like in Confluence or Teams or SharePoint, those types of files, that's you really need one for there because it's almost impossible to manage that without it. Um, within a database, I think that's a good idea. I think having one that does it automatically. Now you still have to tell it what you want it to, what the classifications are, right? Um, so you still have to understand what it is you want to, how you want to identify the data. But I think that's a good idea in general.
Cool, 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 cool. That's it for my questions. I'm sorry for taking a lot of the time.
I'm glad to answer questions. Others?
You're so stingy, Mark. No, just common. I think that most of the times people aren't aware or just vigilant when it comes to just data in general, whether it's hard copy or digital. Uh, I know I work with a lot of hard copy data and a lot of it digital. And when it comes down to the security or classification of that, I've seen some very relaxed or just non-understanding of what needs to be done. Some of the stuff that we do is you know, one of the things that they have within the organization I'm with is the printing, and they do have settings to secure. A lot of times there's people that print out financial records in their organization, but one of the things that we've noticed is that when people print, they don't always go to pick up the documents that they just printed unless it's being printed right in their office. So they did come up with a nifty way of taking care of that with like secure print. As far as if you print something, you're going to have to go to that printer, enter your own security code, and then release it. So, and we've noticed a lot of that.
Smart.
People just don't think about that until we've actually spoken to them about it. And they're like, wow, yeah, that's something we should probably take in consideration.
Yeah. It's new. Others?
I don't have a question. It's just a huge subject, and I appreciate your presentation, and I want to go back through it and look and see what I missed at first glance. But um, it seems like most of the companies I've been with over the years, it's such a large subject that it doesn't get done or doesn't get done into the scale that it needs to be.
Yeah.
Yeah. Thank you again.
Well, okay.
And he is right as far as the levels and steps that need to be taken to secure just data at rest. I mean, I wasn't joking about the military as far as what they keep track of, how they keep track of it, and how meticulous they are. I remember one of the documents that we use for ComSec. If you made a mistake on that document and corrected it, you would have to do a memorandum explaining the mistake that you made and why you corrected it and how you corrected it in detail. So, I mean, it's like, thanks for triggering me, Dave. I will sleep easy tonight. I promise.
Good, good. Okay. Thank you. Looks like there's a post here for upcoming events.
Yes, absolutely. These are some of the events that we have coming up. Our next meeting is November 17th. Our speaker is Derek Sharp. His topic is Every Battle is Won Before It Is Ever Fought. I do want to remind everybody, December, we have no meeting. So we'll miss you. And these are just a couple of the meetings and events that are going on throughout North Carolina and some of the other organizations that we follow and we like to promote. So if you'd like to join or see what this is about, go ahead and join us on our Slack. They are posted there as well. I do want to do a shout out to Raleigh ISSA's book club, Hacking the APIs, hosted by Manny Landron, sorry. Mind-blowing. It's fun. It's adventurous. If you get a chance to network with Manny, he is on LinkedIn and he is open to networking and he is very open to sharing his knowledge. So if you have some time, reach out to him and say hi. And I would like to personally thank you, Dave, for presenting to us for our meeting. We really appreciate it, and great topic, and probably a conversation started for some of us at the office tomorrow.
You're welcome.
All right, and we are at the top of the hour, y'all. Unless there's any more questions, comments, concerns, we'd like to thank you for attending our meeting, and we look forward to seeing you next month.
Thanks all.
All righty. Well, have a good night, everybody.